Can you see my screen?
Yes, bro.
Yeah. So our agenda is about the Linux administration, and I'll give you a brief introduction about operating systems today. And our main motto to work on DevOps, in this class, particularly in this session and as well as the other sessions, it will be mostly on the Linux, as I said and mentioned earlier. So I'm going to give a brief introduction about operating systems, underlying system, and as well as how we're going to use it in the future as well. Here, the operating system, it's very, very niche. Means if you don't know operating system, you're not going to make it in the DevOps. As I said it earlier in the classes, yesterday class and as well as today's class. But I'll give you an outline about operating system. That what is the operating system? Do anyone can give me a brief answer about operating system? I will just go back to the slide DevOps. So I just want to know about what's the operating system from your end. Any one of you. Anjani, Madhu, Shiva. I want to be more interactive with you. Don't be scared. I'm just trying to make you understand more from what you learned previously. No? Okay. So an operating system is the one acts as a medium between the hardware and the software. You have a phone. For example, you have a phone. You have a hardware for it. What do you have a hardware? It's your iPhone with 16 GB of memory and some 256 GB of SSD inside it. That means hard drive or whatever you have. And you have the display to show something like videos or text messages, everything. Even if you call, if you get a call, you will be receiving from the display itself. So you whatever you see is a software, and whatever logic run inside it's a software as well. But something in the background need to be present to work that software. What is that? That's hardware. So you have a hardware, you have CPU, RAM, as well as some connectors, transistors, and even you have in a particular CPU of a iPhone does have billions of transistors. Now someone says that trillions of transistors in past few years as well. So technology is improved a lot from the very beginning. You know how small the largest computer built in 1960s, 1970s, the first computer when they built, that was size of a big room, or you can say it's a size of a two-bed bath house, and it just had 8 GB to 60, sorry, 8 to 16 MB of memory in it. That small the capacity it has. But now in your hand, you have a operating system that is running on a RAM which is equivalent to 16 GB. That is way, way more than thousands of times more than what you have in 1950s and 60s, which is very, very small size than what you have in your hand than compared to the size of a big house. So that's fast the government and as well as the people want to make integrating the operating systems and everything inside your phone, or even telephones. If you see the telephones previously, they are working on some kind of mechanical devices, the wired thing. It had some kind of logic inside it. There should be a round disk type something. It used to have numbers, so you have to press it. It has some logic. When you click a 8 number, you turn around it and it will be clicking on some particular end. So that is where it's calculating from where you start and where you end. And from there, it will take the number 8 or from the 0. So previous in 1990s and 1980s, some of your home might have, right? Those telephones where we used to rotate that particular thing. So how it is stored at that time? It is a very small technology, but very widely used. It uses the logic number inside it, that how many rounds it takes to rotate a particular disk. In the same way, there is also a small kind of operating system running inside it. There's a logic running in the background, and the hardware which we use mechanically, that is a disk which will be rotating. So it will store some number inside it and it will try to dial your number. Later we got buttons where we used to press button and it used to store the logic inside the telephone, and it used to connect to the telephone operator like BSNL or Geo or anything. Now everything is digitalized. You just need to touch it, and when you touch a single digit, and it will translate into a code, and it will send the, if it is a 10-digit number, then it will directly take you to the telephone operator of your Verizon, AT&T, anything, T-Mobile. There are so many providers previously and now, but the technology has improved a lot from past 60 to 70 years till date. What is the change here? Operating systems, hardware, software, everything is changed. But logic is improved a lot. Software, which is interacting with the operating system, with the hardware is the same. Whatever we have from the past 70 years, 60 years, it doesn't know what we are trying to do. Hardware improved a lot in its size, decreasing the size. That's it. There is nothing new we are going to add into the hardware. It is a size what we are decreasing. But the software, we are going to increase the more and more automation inside it. So if you are doing more of lot of software, lot of decreasing the size of the hardware, so there should be a medium, right? Handling the software and hardware, that is the operating system. So operating system is a medium to handle the software which you are trying to run in your phone to the hardware you have. Very best example is your iOS. iOS is the software operating system which is running in your iPhone to maintain the fastest hardware you have in the world, in the hand with the mobile. You have it, but you don't have a good, you have very good hardware with you. Like you have some 200 GB of RAM and some hundreds of GBs of memory with you. You have very good transistor, which can, that is a CPU in very small thing, you can say, very fastest CPU you have in your hand. But if there is a very bad software you are handling, that's a waste of your hardware. In the vice versa, you have a very good software and it can run anything. Like for example, the open AI right now, what we are trying to use, the AI, artificial intelligence, it can be unbeatable for the human technology, human brain or whatever you have. So you cannot match with the AI to your brain. In the same way, right now AI is so developed and it is so fast that right now the hardware is unable to cope or match with the software what we have. So they are trying to build a very good software. That's why Nvidia got so much of reputation, that it is because it is trying to handle the open AI from past 2 years. And now some deep seek, just before 2 to 3 weeks back, we got a news that DeepSeek is trying to overtake OpenAI. How? Because of the hardware which is trying to use. Very small hardware, or the very old hardware can also handle the DeepSeek AI. See, this is where the software is matching with the hardware, but the underlying thing, how AI works with the models. So the operating system that needs to run between the software and hardware, that should be very precise. That is the operating system, Linux, Windows, iOS. These are all the things that trying to gather the operating system in the back end with the hardware, and the front end with the software. So you ask me, hey Kishore, how you can define operating system with the hardware level and the software level? So I'll give a very small example. You have a logic that you need to type a number. Any number, take from 0 to 10, you have to take some random number. So you have to just type in your keyboard. Okay, choose one number, Siva or Anjani. Choose one number of yourself.
6, Kishore.
Okay, so I just typed, I'll take a notepad. Okay, I just type 1 here. How my hardware knows that I just, sorry, you told 6, right? 6. So I just type 6. So how hardware knows that I type 6? Is there any guess? Can you guess? So I'll explain you here how hardware knows it's 6. First, this is a software what you're trying to build, right? The notepad. It is also a software. The operating system I'm running here is Windows. That's the operating system level. In the ground, hardware doesn't have any logic. Hardware knows only zeros and ones. So hardware, whenever we are trying to give any input, it will take in binary system, that is zeros or ones. Okay. So in my language, uh, what is binary digit? Sorry, you cannot see my this one, right? Digit, binary, sorry, binary number for 6. So it's 110. Whenever I type 6 here, the software will decode into 110 and it will send uh, where will be the 110 will be given to the hardware, not the software where you are trying to use. It's not the notepad, it is trying to send the information to the hardware. It is the information sent by the operating system. Operating system will handle this 110. That is not, I am saying it's 110, but operating system will say to the hardware, underlying hardware, whatever the CPU I'm using, it will say 110 is the input given by the software. It doesn't even know what kind of software is running on the top of the operating system. Okay, that is Notepad, or I'm trying to run some kind of virtual machine, or even I'm trying to run Chat GPT, or I'm trying to run VS Code, anything. It doesn't know anything. It only knows, the hardware knows zeros and ones. Okay, when, even if you move the cursor, I'm moving from this location to this location. How do hardware knows that it is trying to move this cursor from one location to this location? It doesn't even know that. My operating system will say this location, it has some access location from the top to the bottom. So it is also stored in kind of binaries. It will say that this some particular location, it moved to the another location. Even the movements also taken into binary code, and it will be changing into the hardware level, that 00s or 100s, whatever it is. So it will convert it and it will say, hey, you want to move from one direction to another direction. The software operating system will say this. Even if you try to run a Java code, it will also be converted into a zeros and ones binary system to the hardware using the operating system. So operating system is like brain or the heart, you can say. If you have a human body system, operating system is like heart. It will be pumping the system to your brain. Brain is like software running your notepad, your Google Chrome, anything. Whatever you run, it's like a logical thing running in the background. But in the foreground, something should be running, right? To say to the hardware that what it is running in the upper portion of your level. That is the one operating system handling to this hardware level. So it's a bridge. Nothing but the operating system is a bridge between hardware and the software. This is a very, very low level I can explain you so that you can understand what's happening in the background of the operating system. So I give you a brief introduction about operating system in the ground. Now we will see what are the things handled by the operating system. blah, blah, blah. You can see operating system serves as an interface between the user and the hardware, providing an environment that enables user to efficiently and conveniently perform tasks. This is what I said in layman language about how the software works with the hardware, right? Did you got any understanding, or do I need to get back to some another example to understand?
No, Kishore, we are good.
Okay.
It's good.
Yeah. So what are the things handled by the operating system? Major tasks. I'm not saying about high level like LAN handling or some kind of very high levels. What are the things you know about operating system if you have already been through the operating system? Majorly the file systems, like a text file. For example, I was going through a notepad, right? It will be saving some kind of file. It might be a .txt file or Java based application ending with the Java, or .NET based DLL file. Anything file which will be ending at the end and stored is a file. In Linux, everything is file. Okay, you can name it as file. Even the directories are called files. I'll be not going to Linux first, but I'll explain you what are the things handled by the operating system. Process management means in the background, there are a number of processes handled by the operating system. Even if you don't run anything of your software, it operating system should itself run some softwares to run it, right? Like uh, the libraries, underlying libraries, the files itself has in the background the root file running system. So it will always start with number one, the root system, root user. There's a process one. So there are so many processes running inside the operating system itself, and at last you will be given some priority based number at last. So that is a process system. We are going to learn more about processing system later class. Now we'll understand that the process. Okay. Next, file management. Third, user management. And I can give you some examples like handling the network. These are all the things handled by the operating system. Okay, we'll go to the next lecture. As I said previously, there is a hardware. You can see the application. There's application here. There's a hardware here. So what's the thing bridge between these two, application software and as well as the hardware? Even the game browser, as I shown, databases, everything is in the outer circle. There's hardware inside in the inner circle. What is the bridge between this? Operating system. Operating system will be handling the hardware and the software as a medium. Okay. Yeah, as I said previously, it's already converted into the binaries, zeros and ones. So to bridge the gap system between the intermediary managing the process and resources in the system. And I'll share this slide as well to make better understanding. Okay. So what are the things you have in a computer system? That is the users, application programs, system programs, operating system, and the hardware. Okay. Who are the users? As I said previously, system itself has a root user. Whenever you press a button of your laptop, what's happening in the background? A small file will be opened which has the root file system, and root user will be starting in the background, and it will run everything init files, and it will be checking all the communication bridge between the laptop hardware and the software whatever it's trying to run. If everything is good, then only it will load. If it doesn't find a booting device or bootable devices, it will stop there and say, hey, something problem in your system. There is a system in the booting process. Have you ever faced that? even if you have low power, sometimes you might get some kind of backend with the white page, and it will say there is a problem with the adapter and it has very low power out input, so we cannot start with this power. Sometimes you might got it. Why all this will be provided by the operating system? Because it should always be met by some criteria in the background. So it will check every criteria in, and if it is passed, then only it will go to the booting process. Okay, so the root user is the one who will be handling the users. Next, application programs. Sorry, coming back to users only, I will be giving you one example. So I'm the one who is also logging to the system computer, right? I'll be also a user. If I give some permissions to other person, then he'll also be user. Users might be anyone, or sometimes it might be domain users as well. Anyone in the domain can also join to this particular operating system and they can also use it. So we'll be talking into it later portion. So you will be understanding better about users in the future classes. For now, you understand users are the one who is handling the computer system. Okay. And next, going to the application programs. Whatever you take the application, it's a program. It will be running some programs in the background. So here I'll give you a very small example. Your browser. Your browser is an application program. In the background, it might be running by the Java or some kind of any programming language. It will give you some interface to show you in the web format. In that format, you can type something and it will be checking some program in the background, and that program will be saying to the network, and that network will go to the Google Cloud, and from there it will fetch, match the data, and it will get back to you using the same routing mechanism to your browser. So it will be happening very fast and you don't even notice that how fast it will be, because it is always running in the light speed. Okay. The same way games, whenever you interact with the games, you play very uh, small games. For example, chess. It has some code in the background that will be running the application. Even you can chase with the level of the gameplay. If it is very hard, it will be running with the more harder program inside it, and that will be very hard to play with the computer itself. If you play with the very low level, the program will be very easy for you, such that any user will be trying to play with the computer. It will always go back to the level one, and it will say, I don't want to give him much pain. So you just give him a chance to play. That's where the programs has some logic in the background to communicate with the users. Okay. Or sometimes the application programs don't need to communicate with the users, like databases. Some databases don't need to interact with human beings. They might be running in the background from the browsers or application. They'll give the data back with the application itself. So application will be handled by the another application. Okay, these are all the programming things we can discuss in the CI/CD pipelines, or the more precise in the application development. But for now, you understand the operating system has always application programs, which might be operating system programs, or it can be a user specified programs. Okay. Next, coming to system programs. These are all default programs which are not developed by the user. If you see the compilers, databases, games, video player, browser, these are all not required by user all the time. It doesn't matter for the operating system if they exist or not. But for the operating system, there are things required for itself that need to be running in the background. That is a shell, like the PowerShell or the Bash for the both the Windows and Linux. Some editors, compilers, these are the things running to change the operating system level to binary system for the inputs whatever we give. etc. So there are so many things in the library level. There can be some programs running. Those are all system programs. Okay. Do you need more information about the difference between application programs and system programs? Are we good with this?
We're good with discussion.
Yeah. Okay. Next, going to operating system. As I said, it's a program access interface between the user and the hardware, or the software and the hardware. Okay. Hardware, anything which you can touch and feel, that's a hardware. Coming to operating system things, as I mentioned previously, there are several things handled by the operating system itself. There is the process management, sorry, process synchronization, memory management, CPU scheduling, file management, and security. So in the upcoming lectures, we're gonna more deep dive into these things for our understanding. That is for the DevOps, not to learn more about the Linux administration or anything, but for this, by understanding these things, you might be landing into a good job. Okay, better understanding about the DevOps. We are not the Linux administrators. Okay, we are users of the Linux. So in future, you might require to handle the Linux administration as well. In that case, it might help you. These are the things which I'm going to teach in the next lectures. Okay, these are the slides for today, but I have something interesting for you. That is the operating system of the Linux. I'll give you a small brief introduction about how a operating system looks like using the virtual machine. In the coming lectures, you might say it. So I'm in the root, I'm not in the root user, but this is a home user for the Linux. This is the Linux box, which I created in the virtual box. This is a virtual box. I have several operating systems running in the background. These are the test machines I was using previously. Today I have created a Ubuntu machine, and you can also create a Ubuntu machine. I'll teach you how to create a Ubuntu machine for yourself. Okay. And here if I just type a command, what is the ls-al? These are all the commands you're going to learn in the next lecture, next few lectures. And I'll show you something. See, this is what we call the root. I cannot go back from this. Everything starts from the root in the Ubuntu. This is the user who loads everything for the operating system. These are the operating system level files, and as well as the operating system level important information. What are the things reside inside a root level of a directory for the operating system is the bin directory. This is the one you're gonna always heard about in the work culture wherever you go, because user and the bin, where you have the binary system files of the system, and users also have the binaries. It is a boot, which is also very, very important thing. That is, boot files will be existing inside it. As I mentioned previously, whenever you click a button, it will always go through the cycle of process checking all the hardware initiated, and as well as the software if it is working properly. This is the folder where you have all the bootable files inside it, the booting system. And CD-ROM, you don't need it because it is for the CD mounting. And device files, device etc, where you gonna file store the information related to some kind of information. I'll teach you. etc files are different from regular files. Okay. And the home directory file, libraries, you can ignore this one, lost and found. We don't need that now. but media is the one which you're gonna have the information related to any kind of softwares you handle, not exactly like user install softwares. It might be some kind of photos, library sets, or anything. And MNT is a mount where you're gonna mount the devices, whatever you have. Okay. For example, if you have a pen drive, if you want to insert into your operating system, mount is the one where you're gonna see the pen drive. OPT is the one where you can see the user installed software. Whenever you install a software, it will always go to the OPT by default, or you need to go to OPT to install it. Okay, where it will handle the user specific applications. Proc is the one for process, root is the one for root directory, and yeah, system related temp, user, variables. These are all the files this is a very basic thing to know about a operating system. These are all the files in the root directory, as I mentioned. So you might not know in the day one itself, but you should learn eventually what the things happening inside the root directory. Okay. So here comes the information for you. I'll give some tasks today. I'll make a file with the questions. So in the coming lecture, we're gonna have some kind of Q&A. You go through those questions. If you have any questions on that given task, just get back to me. I'll give some time to you and you can ask me and I'll rectify those questions. And second thing, for the upcoming lecture also, I'll give you some questions and you can learn by yourself the things so you can understand what's happened today and what I'm going to teach tomorrow. Okay.